All of you keep heading. Rutherford's alpha particle scattering experiment. I'll teach you what is alpha particles also. Rutherford's alpha symbol this is. Okay. So bracket you can write ALPHA, particles, alpha particles, scattering experiment. So whenever, as I told you, when you speak about the Rutherford, immediately the first point you have to remember what, guys, everybody? Discovery of, yes, please. Discovery of nucleus.
Yes.
Okay. So who discovered the nucleus? Mr. Arnold Rutherford. So now, in this one, once the discovery of electrons is found by Mr. J.J. Thomson, it is increases the curiosity. Many scientists, they're started working on about the structure of atom. So the secrets of atom was revealed by, majority of the secrets is revealed by Mr. the Ernest Rutherford. Ernest Rutherford, after the initial attempts of Thomson to explore it. So as the Thomson said 3 points about the structure of atom, in that only how many points is valid point? I already told you.
1 point.
1 point. The point number 3. That is what? Atom is electrically neutral. So the charge of the atom is 0. So now about this Rutherford, so let us take. So he has been taken alpha ray scattering experiment. That is the first thing you have to remember. A part. So we'll discuss what is alpha ray scattering experiment, later observation, later conclusions, later what is Rutherford atomic model. So these many things you have to discuss. Here it is a very big one, and this is the most important one. Right. So first we are going to discuss about alpha rays, alpha rays scattering experiment. So what is alpha rays? We are going to discuss now. And what is this experimental setup? We are going to make it. So your book, you will be having a diagram of scattering of alpha particles by the atom of gold foil. That is the experiment, actually the observation of Rutherford. But you do not have the exact structure of what is the diagram of Rutherford experiment. So now first we are going to see that, and then we are going to go with the observation. So do you all have NCERT book, everybody? Yes, please. All of you.
Yes.
You open your,
Yes.
you might be having this diagram. Have you checked it, everyone? All of you, please let me know. Verify it and let me know. Have you checked it? This is the diagram you have, but the experiment you do not have. This is the observation of Mr. Rutherford. This is the observation of Mr. Rutherford. This or this. But the exact experimental setup is this one. So this is the experimental setup of Rutherford's scattering experiment. So please draw this and make it, and then we can make. Okay, everybody. So this is the screen. You can see almost it is covered 365 degrees. Only small opening, and this is the gold foil. A very thin gold foil. What is this one, everybody? A thin gold foil. It is already mentioned. Almost imagine the gold foil thickness is just about 1,000 atoms. 1,000 atoms. Eighth class you might be studied. Which metal is the highest malleability? Everybody? Malleability. Yes, please. Highly malleable. Gold. That is what.
Gold.
Yes, that is the reason we have been taken the gold here. Do you all understand, everyone? Clear, everybody? Because it can be formed as thin as possible. So he has been taken a gold foil about how many atoms, everybody? He has been taken a thickness of about 1,000 atoms. Imagine 1,000 atoms, how small it is. Okay. So now alpha ray scattering experiment. This is what is the alpha ray scattering experiment. So this is the source of alpha particles. So what is mean by alpha particles? Now I am going to say you that. So alpha particles means, please remember, they are the positively charged. Write it everyone. Positively charged, positively charged helium nuclei. That is what He2 plus. He2 plus. That is what we used to call it as alpha particles. Everybody clear? All of you? Yes, please. And He2 plus means what is the positive charge present in the helium? Anybody? What is the positive charge present in the helium? Speak loudly. 2. Do you understand everybody? So the positive charge is plus 2 units. Plus 2 units. And the helium has 2 protons and 2 neutrons. Can you tell me what is the mass? What is the mass carries it is? The mass carries by it is. Yes, please. The carries the mass of how much, guys? Carries the
3.
mass of 2 plus 2. How much it is?
4.
4. Carries the mass of 4u and the charge of how much, Amma? Charge of
2 plus.
2 units. This is called it as alpha particles. Alpha particles, they are the fast moving. They are the fast moving positively charged helium nuclei, which is He2 plus. Means, please remember, if you remove the electrons from the helium, basically helium is a what actually? Helium is a noble gas. Am I right or wrong, everyone?
Yes,
Yes,
sir.
please. So helium, I will teach you again in this chapter we will study. Please note it everybody. So helium is actually having 2 electrons. Nucleus, it is having 2 protons plus 2 neutrons. So that the atomic mass is equals to 4u. Atomic number is equals to 2. Now if I means in the sense of it has how many electrons? Everybody speak loudly. It has how many
2.
electrons? 2 electrons. Clear everyone? So this is the helium atom. Now, if I remove the 2 electrons, remove 2 electrons, then only positive charge is there. That is what helium atom. 2 protons and 2 neutrons. That is what electrons are gone. So that is what we used to say is He2 plus. This is the helium ion. Is it okay, everybody? All of you?
Yes, sir.
Yes, helium ion. So what do you mean by alpha particles, everybody? Alpha particles means what? A positively charged helium nuclei means He2 plus, whose charge is 2 units and who it carries the mass of how much, everyone? Carries the mass of 4u.
4.
4u means what? 4 AMU. What do you mean by AMU? Atomic
Yes.
Atomic mass unit.
Mass.
Clear, everyone? So till here, any doubt you have to ask me. Please note it. Very, very important. If you understand this, then we will proceed further. Make it quick. Shivani, understand? Kavya, Sangamitrai?
Yes, sir.
Yeah.
Yes, sir.
Are you clear? Mukesh?
Yes, sir.
Do it fast. Any doubt anyone have? Please ask me. Clear, Mr. Sam? Prithvi? That is what. So now, let us see. See, everyone studies the scattering of alpha particles. That is what, as I told you, everyone will study only this. But what is this exact experiment? Let us see. I share this diagram and you have to draw in our classwork also, all of you. So this is what is the diagram, experimental setup, schematic diagram of Rutherford experiment. Yargi theriyadu, you have to write. So now that virtualization we'll discuss, and then we are going to come back and we are going to make alpha ray scattering experiment. What is the observations? Okay, everyone. So now let us make it here. So this is the visualized experiments of alpha particles scattering Rutherford's experiment. So make it, and any small doubt also please have to ask.
रे स्कैटरिंग एक्सपेरिमेंट जे थॉमसन पहले साइंटिस्ट थे जिन्होंने पहला एटॉमिक मॉडल डिस्कवर किया।
I will explain you, don't worry.
इस एटॉमिक
Just
मॉडल
watch.
को उन्होंने पल्म पुडिंग मॉडल नाम दिया।
So plum pudding model means we already studied. What is that, everybody? Entire cake is a positive charge, and the dry fruits we used to call it as a what? Negative. Everybody, negative charge. And he only said that J.J. Thomson, amount of positive charge is equals to amount of negative charge. That's why atoms are neutral. Understanding? Electrically neutrality. So that is what we discussed. Is it right, guys? Mr. Gokul, Kishore. Now let us.
लेकिन इस एटॉमिक मॉडल की कुछ लिमिटेशन थी, जिसके कारण ये एटॉमिक मॉडल एटॉमिक स्ट्रक्चर को एक्सप्लेन नहीं कर पाया। अर्नेस्ट रदरफोर्ड, जो कि एक ब्रिटिश साइंटिस्ट थे, वो जे थॉमसन के इस एटॉमिक मॉडल से सहमत नहीं हुए, जिसके बाद उन्होंने एक एक्सपेरिमेंट किया। रदरफोर्ड ने इस एक्सपेरिमेंट को अल्फा रे स्कैटरिंग एक्सपेरिमेंट नाम दिया और इस एक्सपेरिमेंट की मदद से एटॉमिक स्ट्रक्चर को एक्सप्लेन किया। तो आइए इस एक्सपेरिमेंट को डिटेल में समझते हैं।
Now I will say you, name it, everyone. The diagram you have to draw. Here the parts I will name it. So this is the source of alpha particles. So which we used to call it as like all of you remember the source of alpha particles, where it is emitted. We will basically says uh, this surrounding material. This is the source of alpha particles, and this surrounding, see that almost it is covered in 360 degrees. Am I right or wrong? This is what we used to call it as a zinc sulfide material. So please write it. A circularly screen coated with what? This screen is coated with what, everybody? Zinc sulfide. Zinc sulfide. So please note it, all of you. So zinc sulfide. Then this is the gold foil. What is the symbol for gold, everybody? AU. Okay. So gold material it is. Then now you can see.
एनिमेशन में हम देखते हैं कि एक रेडियो एक्टिव सोर्स को लेड ब्लॉक यानी ग्लास कंटेनर में रखा गया है।
So what is this one, everybody? It is a block of lead, radioactive material. So which will emits the what particles, everybody? Which will emits the what particle, all of you? Yes, please. Alpha particles. Which will emits the what particles? Alpha particle. What do you mean by alpha particles? Everybody. He2 plus. He 2 plus particles. Okay.
इस रेडियो एक्टिव सोर्स से अल्फा पार्टिकल्स एमिट होते हैं। एक अल्फा पार्टिकल हीलियम न्यूक्लियस के बराबर होता है, जिसमें 2 प्रोटॉन और 2 न्यूट्रॉन्स होते हैं। इसका मतलब एक अल्फा पार्टिकल में 4 यूनिट मास और 2 यूनिट पॉजिटिव चार्ज होता है।
Do you all understand what is alpha particles? Please let me know, everybody. Are you all clear or not? Alpha particles means? Everybody?
Yes, sir.
Please respond. So that is what? So what is alpha particles? Everybody? Positively charged He2 plus ions. That is only call it as alpha particles. Okay?
रेडियो एक्टिव सोर्स के आगे एक थिन गोल्ड फॉयल को रखा गया है, जिसकी थिकनेस लगभग
What is the thickness of the gold foil, everybody? The gold foil with a thickness of how much, guys?
1000
1000
atoms.
atoms. That is what? A thickness of 1000 atoms. That is very thin.
210 नैनोमीटर है।
That value also they mentioned here. Please learn. This value you cannot be finding in the books and all. They will say in books 1000 atoms. Understanding the gold foil with a thickness of 1000 atoms. It is how much it is? 210 nanometer. 210 nanometer. And last chapter we studied 1 nanometer is equals to 1 nanometer is equals to how many meters? Everybody. 10 power
10
minus
power.
10 meters. Minus 10 or minus 9?
Minus
Minus
9.
9. Okay, minus 9 nanometer. So imagine how much thin it is. Okay, so do it. All of you.
इस गोल्ड फॉयल के चारों तरफ जिंक सल्फाइड की स्क्रीन लगाई गई है।
The screen is coated with what, everybody?
Tin
Screen is
sulfide.
coated with the zinc sulfide. So that is you have to remember.
जिसकी मदद से अल्फा पार्टिकल्स को डिटेक्ट किया जा सकता है।
So what is the use of that? Anybody? What is the use of that? It will detect the alpha particles. What will happen? Everyone? It will detect the alpha particle. Do you all understand, everybody? Please respond, guys.
Yes, sir.
Yes. So zinc sulfide will detect the alpha particles. That is what? What is the formula? Anybody can tell? You all know zinc sulfide. Formula, please. Any one of you. Zinc sulfide formula. Coating with the zinc sulfide. Zinc sulfide formula, please. Zn sulfide. Sulfide. Yes. So what is the zinc valency? +2. Sulfide valency -2. So what is the formula? Zn2S2, which is equals to Zns. See why I need to say you this now? Because again, you should not be forget the formulas by writing crisscross method. Always it has a greater importance. Next entire class 10th we have use of this. That's why wherever chemical compound comes, learn the formula, how to write properly. That is what is my intention. I hope you all understand. Anybody having any doubt, please ask me. So the screen is completely coated with what, everybody? All of you? Yes. Zinc sulfide. Why? Because it will scattering of alpha particle. It will detect the alpha particles when it will hit. That is what it is. Okay, everybody?
गोल्ड फॉयल और रेडियो एक्टिव सोर्स के बीच में एक ग्लास स्लिट को रखा गया है।
So why the slit? What is the use of slit? Anybody? He is middle, he is putting a slit. What is the use of it? Anyone? Just to pass the light alpha particles only through the one gap. Do you all understand what I'm saying? Alpha particles will be emitted, can be go in a different directions, whatever it is. So, but our experiment is what? We have to conduct the experiment in such a way that only alpha particles has to go through the particular direction and need to hit the gold foil. So that is why they are putting one slit. So slit means a slit is a small opening. So you can take, for example, there is a cardboard. A slit means there is a cardboard and middle one small, if I cut it, that is what we used to call it as a small hole. If I make it, that is what we used to call it as a slit. Is it okay, guys? Do you all understand, everybody? Speak, guys. So light will pass through that. Understand, Amma? Everyone,
Yes.
that is
Yes,
what.
sir.
So you have to make some slit so that the light can pass through that.
जिसकी मदद से अल्फा रे को स्ट्रेट और नैरो प्रोजेक्ट किया जा सकता है।
I hope you all understanding. Mr. Mari, Lingesh, clear? Anything doubt? All of you? Yes, please. If you understand this experiment, then observations and all very easy. So just observe this one, and this experiment has to be there in our brain to study the observation, to study the conclusion, and to study the model of Rutherford. So please remember that and make it.
एनिमेशन में हम देखते हैं कि जब अल्फा रे को लेड ब्लॉक से प्रोजेक्ट किया जाता है, तब अल्फा रे स्लिट से पास होते हुए गोल्ड फॉयल पे फॉल करती है। अल्फा रे में जो अल्फा पार्टिकल्स है, वो गोल्ड फॉयल से स्कैटर होते हैं और डिफरेंट एंगल पे डिफ्लेक्ट होते हैं।
Have you noticed it, everybody? So as we are sending the alpha rays, alpha particles, millions of alpha particles will be there. So now in this, majority of the alpha particles passing through the gold foil and they are just deflecting and they are scattering at the zinc sulfide screen. Scattering in the sense of the path is visible to us. They are deflecting towards with a lower angle, and they are forming on the, we can notice that in the zinc sulfide screen. And you see, some alpha particles are scattering too much. Have you checked it, everybody? All of you? Some alpha particles are scattering very, very too much, more angle, and they are hitting at the far even. Observe that experiment, everybody.
ये अल्फा पार्टिकल
And have you noticed that some alpha particles are even deflecting too much and they are coming this side? Have you checked it, guys? Please let me know, everybody. Do you all notice it? Yes or no,
Yes,
guys?
sir.
Yes.
Yes,
Now,
sir.
observe carefully, and after certain time period, there is one and only particle will be takes reverse path. That is I want it. You have to observe that. Check it.
पार्टिकल्स जिंक सल्फाइड स्क्रीन पर एक ब्राइट फ्लैश लाइट प्रोड्यूस करते हैं, जिसकी मदद से अल्फा पार्टिकल को डिटेक्ट किया जा सकता है। आइए अब जानते हैं इस एक्सपेरिमेंट के ऑब्जर्वेशन के बारे में। ऑब्जर्वेशन ऑफ रदरफोर्ड्स अल्फा रे स्कैटरिंग एक्सपेरिमेंट।
You observe, no, nothing. We'll study it.
फर्स्ट ऑब्जर्वेशन।
See, this is important for you. Tomorrow, if I says what is your observation, you all should not again depend on school points and the book points and all. You, sir, this I observed from the experiment. Now, I'm giving you chance to you people. You tell me what is your observation from this? What is your observation? When the alpha particles are hitting this, so what is happening? Many of the alpha particles are deviating very less angle. Am I right or wrong, guys? From the original
Yes.
path? Yes or no? Next, very few alpha particles are deviating more. Understanding? And that is what it is. More than 180 degrees. See, some alpha particles are deviating more than 180 degrees. So that's all it is. That is only your observation. Nobody will ask anything. And remember, very few out of 12,000 alpha particles, just one alpha particle out of 12,000 just turned back in the same direction. Very few. Like we can say, count is in less than 10. Out of every 12,000 particles as projected, alpha particles, a very few particles will retray in the same position. They will be back in the same track. This is what is our observation. Do you all clear, everyone? Very few alpha particles will be in the same track, and very few is deflecting with a greater angle, and most of them are deflecting with a less angle or more angle. Everybody, less angle or more angle?
Angle.
Less angle. And many of them, they are going in a what line? Many of them, they are going in a what line? Straight line. And they are going through the gold file. So that is only your observations. So let us see.
ज्यादातर अल्फा पार्टिकल बिना डिफ्लेक्शन के स्ट्रेट पास हो गए। Most of the fast-moving alpha particles passed straight through the gold foil.
That is the first point. Write it, everybody. The diagram I will share, you have to draw. So keep reading, everyone. Observations. Observations. What is the first observation, everybody? Most of the alpha particles, fast moving alpha particles, passed through the gold file without any deflections in their straight line. That is what you have to write it, or simply you write this. Most of the fast moving alpha particles passed straight through the gold file. Passed straight through the gold file. Clear, everybody? Mr. Pranav, Nivedan, Sam?
Yes,
No use.
yes, sir.
Do it. Pradhana, do you understand? Next, do it. First observation. Clear, Mr. Mari? Second observation.
Second observation.
See that. Very few particles, they are deflecting more than 180 degree. Larger angles. Very few particles, they are deflecting with large angles.
कुछ अल्फा पार्टिकल्स बहुत स्मॉल एंगल पे डिफ्लेक्ट हुए। Some of the alpha particles were deflected by the foil by small angle.
And
Third
very
observation.
few deflecting what? Everybody, very few deflecting with the large angles. That is what.
लगभग हर 12,000 पार्टिकल में से एक पार्टिकल गोल्ड फॉयल से टकरा के 180 डिग्री पे बाउंस बैक हुआ।
Here. Have you noticed that? This one, which is coming back? Everybody, Agalya, can you notice Shivani? Yes, please.
Yes, sir. Yes,
So
sir.
very few out of 12,000 particles just turn back in the same direction. Very few. Do you all clear, everybody? Please respond, guys. Very few deflected with a small angle. Very few deflected with the large angles. And very few will be take back in the same direction. This is only the observation of Mr. Rutherford in his
Surprisingly,
experiment.
1 out of every 12,000 particles appeared to rebound.
Rebound. What do you mean by rebound? Everyone. What do you mean by rebound? Bouncing back in the same path. Bouncing back in the same path. That is what you have to remember. Try it. What is the second observation, everybody? What is the second observation? All of you. Second observation. A few alpha particles were deflected. A few alpha particles. Few alpha particles.
Moving particle.
Yeah. A few alpha particles were deflected with a small angle, and a few with what angles, everybody? With the large angles. That is what. Okay, everybody, that is the second point. And third point is what? Out of every 12,000 particle, one particle will be what? 1 out of every 12,000, it will be turned back in the same direction. Turned back in the same direction. What is the word we'll use properly? Rebound. Okay, so that is what you have to remember. I hope you all understand. Everybody, everyone understand? Shivani, Kavya, any doubt? Please let me know. Everyone, Pranav, Mr. Jay Krishnan. So this is only the alpha particles experiment. From this, we will discuss what is the conclusions made by Mr. Rutherford and what is Rutherford atomic model in the later. So first you have to be very clear with this. Any doubt, please ask me, otherwise make it. So totally how many observations Mr. Rutherford's made? 3 observations. Clear, everybody?
इन सभी ऑब्जर्वेशंस को ध्यान में रखते हुए रदरफोर्ड ने कुछ कंक्लूजन्स या
Conclusions is not required. Now we'll go back to the observation only. So this is what is that. So conclusions will make it later. So now this is what is the observation. So all of you observe majority of the particle. All of you read what is your first observation. You have to learn this diagram also. Exam also they will ask this. What is your majority of what is his observation? Everybody. What is his first observation, Amma? Majority of the particles are going in a straight line. Do you understand, everybody? So majority of the alpha particles were passed through the gold foil without any deflection in their path. They went in a straight line. Without any deflection. And next, second point, very few particles, have you noticed it? A very few particles are showing the deflection with a small angle. So see that very small angle they are deflecting. Have you checked it, everybody? I want response from everyone. Have you checked it, everyone? So from the original path, very small angle they are deflecting. And very few they are deflecting more, larger angle. Have you checked it? Almost you can see greater than 180 degrees they are deflecting. So almost very large angle they are deflecting. See that more than 90 it is deflected. And very one particle out of 12,000, one particle it is bouncing back in the same medium, the same path. That is what out of every 12,000. So this is what is the observations made by Mr. Rutherford from his alpha particle experiment. Anyone having any doubt, you can ask me. So this is the experiments. You have to draw 2 diagrams. This is what is the experimental setup and this is what is the scattering of alpha particles by the atoms of gold foil. Anybody having? You can ask me. Anybody has doubt? You can ask me, guys. Clear, everybody? Yes, please.
Yes, sir.
Now, people will think that, as I told you, Mr. Rutherford discovered the nucleus. But you know who discovered the nucleus? It's not that Rutherford. The assistant of Rutherford, Hans Jaeger, he is the one who has discovered the nucleus. Understand, everybody? During the same experiment. So when Rutherford noticed that the number of alpha particles scattered by an angle of greater than 10 degrees. What is the angle, everybody? All of you? 10 degrees, greater than 10 degrees, so that much more than it is predicted. So notice that, everybody, one of the assistants of Rutherford noticed that the number of alpha particles were scattered, the angle more than or greater than 10 degrees. 10 degrees, then only he noticed that there is a positive charge which is located only at the center, and remaining all entire atom is having the free space. So that is the discovery of nucleus. So who has been discovered the nucleus? Hans Zeiger. Okay, he is the assistant of Mr. Rutherford. Remember that and do it, everybody. Okay, guys. Mr. Prithvi? Yes?
Yes, sir.
Yeah. So now you see, all of you, and also there is another point which many people don't know. So when this bright flash, that is what alpha particles were observed on a circular skin coated zinc sulfide, so because of scattering, so he assumed alpha particles to be much heavier than the protons and expected that alpha particles were deflected by subatomic particles which is present in the atoms of gold foil. But he did not expect such large deflections. Actually, Mr. Rutherford thought, as it is, he is passing the helium 2 plus. Am I right, everybody? He is passing the helium 2 plus. What is the mass of it? Everybody, what is the atomic mass of it? 4U. Right or wrong? So it is actually a greater mass. It is a greater mass. He thought that, he expected that when it is passing through the gold foil, definitely these particles will stuck there. They will never pass through the gold. He never expected that they can easily pass through the gold foil. He thought that they will stuck there. The results are behind his experiment, his expectations. He expected that the particles, Rutherford thought that this positively helium ions, they will stuck in the thin metal and only some of them will scattered instead of continuously scattering more number of particles. So that is what he thought. But the thing is, his results were completely more than beyond his experiment. Unfortunately, he noticed that majority of the alpha particles are scattering, means they are easily passing through the gold foil, very few with the less deviation